Today we're doing Math 6th, Mission 1, Lesson 5, Bases and Heights of Parallelograms. So use the diagrams below to answer the questions. Elena found the area of the parallelogram like this. So it looks like she started from a corner and she decomposed and then recomposed it over on the other side. Tyler found the area of the same parallelogram like this. So he also decomposed and then recomposed, but he did not start at a corner. Both ways are correct. How are the two strategies for finding the area of a parallelogram the same? Well, they both decomposed and recomposed into a familiar shape. And that familiar shape is a rectangle. How are they different? Well, Elena decomposed into a 90-degree triangle to move hers over. Tyler decomposed into a quadrilateral. A quadrilateral is a four-sided shape. Okay, he decomposed into a quadrilateral and moved it over. Both are fine. My preference is to start at a corner, but both are fine. And they recompose. So, Elena, how do you spell Elena? Oh, E-L-E. Elena decomposed into a triangle, and Tyler decomposed into a quadrilateral. Both are fine, it's just a preference. All right, let's go to activity 1. Each parallelogram has a side length that is labeled base. Study the examples and non-examples of bases and heights of a parallelogram, then answer the question. All right, so the dashed segment in each drawing represents the corresponding height for the given base. So if you notice, we have base, and then this dashed line right here, and that is the height. So again, we have a base, and then we have the corresponding height. Base, height. Base, height. Non-example, the dashed segment in each drawing does not represent the corresponding height for the given base. So here's the base. This height, this is not a height for that base. Okay, so if we go back over to the example section, you will notice that each one of these dashed lines run into the base with this square right here. And if you remember from last time, this square means that it is a 90-degree angle. Okay, a 90-degree angle. In order for it to be a base for that, in order for it to be a height for that base, it has to hit at a 90-degree angle, which means they are perpendicular. They cross at a 90-degree angle. Okay. So notice this is the base. Does it have a square there where the height meets it? No, because it does not come into the base at a 90-degree angle. Same here. Here's the base. This again does not have a 90-degree angle. Here's the base. This height does not come in at a 90-degree angle. Now, you might say, Mrs. Covert, there is a 90-degree angle square there. That is true, but look where they've labeled the base. So that 90-degree angle would have to come in to the base here at 90 degrees, and it does not. So this is not the height for this base. All right, select all statements that are true about the bases and the heights in a parallelogram. Only a horizontal side of a parallelogram can be the base. So horizontal means running this way. Well, that's not true. We do see that here, but we have a vertical base here. And then this base is kind of at an angle, so it's not really horizontal or vertical. And again, here, this base is kind of at an angle as well. So this is false. It does not just have to be the horizontal side. B, any side of the parallelogram can be a base. Yeah, we can see that. So that is true. A height can be drawn with any angle to the side chosen as the base. No, we have just talked about the fact that it has to be a 90-degree angle. So this is false. It can't be any angle. It has to be 90 degrees. A base and its corresponding height must be perpendicular to each other. Yeah, remember, this is perpendicular. Perpendicular lines, when they cross at 90-degree angles. So this is true. It must be at a 90-degree or perpendicular angle. A height can only be drawn inside a parallelogram. Well, that's not true because right here we have a height drawn outside of the parallelogram. So this is false. A height can be drawn outside of the parallelogram as long as it's drawn at a 90-degree angle to the base. Yeah, but it has to be a 90-degree angle to the base. So this is true. A base cannot be extended to meet a height. Well, that's not true because look, this right here is our base and it's been extended out to meet the height. Now this works because that's like taking this here, cutting this down, and moving it over. Let me do that again. Like this. Like that, right? And then moving it over, decomposing and recomposing it into a rectangle. So yeah, the base can extend to meet the height, so that is false. What you have to be really careful about though, and I'm going to erase this so you can see it. When we measure the base, we only measure the original base. We do not include this section. We don't include that section that has been extended to meet the height because that's not a part of it. All right, here we go. 5 students labeled a base B and a corresponding height H for each of these parallelograms. Are all drawings correctly labeled? Explain how you know. Well, if we go back up to this true and false, we know that any side can be a base. We know that a base and the height must be perpendicular or meet at 90 degrees. And we know that a height can be drawn outside of the base as long as it's at a 90-degree angle to the base. So let's think. Okay, here's our height. Here's our base. Just because the base is on the top doesn't mean it's not a base. So does the height and the base meet at a 90-degree angle? Yes, it does, because we have that little box there that indicates that it is at 90-degree angles. Any side can be a base. It meets at 90-degree angles. So we're good. The height goes from one side to the other side. That's important too. We can't just have, so this would not be a height because it doesn't go from one parallel side to the other. Okay? So that couldn't be a height. So yes, the height and base of A are correct. Let's look at B. Remember, any side can be a base, so this is fine to be the base. But does that height come in at a 90-degree angle? Nope. So B is not the right height. If we were going to draw the right height, we would have to draw it like this so that it hits the base at a 90-degree angle and goes from one parallel side to the other parallel side. Let's look at C. We have a base. Any side can be a base. Does the height go from one side of the parallel line to another side of the parallel line? Yes. Does the height hit the base at a 90-degree angle? Yes. And finally, remember, the base the height can be drawn outside of the parallelogram. So even though the height is outside, it's still okay. So C is 1. Let's look at D. D has this side as the base. The height here goes from one parallel side to the other, and it comes in at a 90-degree angle. So D is also correct. E, we have one side as the base, which is fine. This height is another side, but it does not hit the base at a 90-degree angle. We would have had to have had the height come down like this at a 90-degree angle. So E is not 1. All right, find the base, height, and area of these parallelograms. For each parallelogram, identify a base and a corresponding height, and then record their lengths in the table that follows. Find the area and record it in the rightmost column. Okay. In the last row, write an expression. An expression is like a formula without the answer, using B and H for the area of any parallelogram. All right, here we go. So I'm going to choose this side as my base because any side can be the base. And then I need the height to come out at a 90-degree angle. Well, I know that rectangles have 90-degree angles for every angle. So I'm just going to go like this. That's my height. So my height for A is 1, 2, 3, 4. And my base for A is 1, 2, 3, 4, 5, 6. So the area is 6 times 4, which is 24 units squared, or square units. All right, let's choose the base for B. I'm going to choose this as my base. So this is my base, and it's 1, 2, 3, 4, 5. And I can't choose a side like this for the base because it doesn't come in at a 90-degree angle. So I'm going to go inside, and I'm going to go 1, 2, 3. It comes in at a 90-degree angle to the base, and it goes from one parallel side to the other. And this is 1, 2, 3 tall. So 5 times 3 is 15 units squared. You can write out units or you can do UN like I did in A. All right, let's go to C. My base, I'm going to choose this as my base. And that's 1, 2 units. And then for my height, I'm going to draw my height outside of my parallelogram, which is totally fine. I can do that. I'm just going to extend my base out to meet it at a 90-degree angle. So my height is 1, 2, 3. So 2 times 3 is 6 units squared for my area. All right, for this next one, I am going to choose this as my base. So it's 1, 2, 3, 4. And my height, I'm going to go inside this time. I'm going to choose this as my height, which comes in at a 90-degree angle to my base. It goes from one parallel side to the other, and it is 1, 2. So 4 times 2 is 8 units squared. So to find the area of any parallelogram, I'm going to write an expression for that, which would be my base times my height. And that is an expression because it doesn't have an equal sign, which is okay because it's just telling us what we should do to then find what it equals. You can also write this BH because when you push 2 variables together like this, or terms, that means to multiply. Have you ever seen this, like 8b? That means do 8 times b. Also, a dot is the same as a multiplication sign. They mean the same thing. That is our lesson for today.